folks, welcome back. We're going to take a look at number 4 and we're going to solve this. And again, I've got some fractions here. I can see I've got a quadratic equation because I have a z squared term, but I'm going to do my best to get rid of those fractions. And we get rid of fractions when we have an equation if we multiply every term in that equation by the LCD. And in this case, the LCD, the least common multiple of 4, 3, and 12 is 12. So what I'm going to do is I'm going to take this 12, I'm going to multiply it to z squared over 4, I'm going to multiply it to z over 3, I'm going to multiply it to 11 over 12, and we're going to see the fractions just go away by design. So let's try that. So I'm going to do 12 times z squared over 4. That's going to be equal to 12 times z over 3 plus 12 times 11 over 12. And then we're going to simplify this and see what everything cancels out to. So the 12 and the 4 are going to go away. That's going to leave me with the 3. So on the left side here, I'm going to have 3z squared. The 3 and the 12 are going to go away, leave me with the 4. So I'm going to have over here 4z. And then the 12 and the 12 are going to go away, and that's just going to leave me with the 11. So now I'm looking at a quadratic formula, or excuse me, a quadratic equation. And I could try and factor this. I could try and complete a square, or I could use the quadratic formula. I'm going to set this to 0 and just see if I'm able to factor this thing. I like to check if I'm able to factor because factoring is faster, but it doesn't always work. So let's see. If I were to set this to 0, I'm going to subtract the 4z over, and I'm going to subtract the 11 over. So let me go ahead and subtract 4z from both sides, and I'm also going to subtract that 11 from both sides. So this will cancel, again, by design, and we are looking at 3z squared minus 4z minus 11 equals 0. And so I would have to determine, is there anything that could multiply to 11 but add to negative 4? Keep in mind there's this other factor of 3 here. And what I mean by that is, if we were going to try and factor this, we could only split the first by 3z and z, and then we can only split the last by 11 and 1. If I go outer inner here, this is 33 and 1. That's not going to get me to negative 4. If I flipped it and went 11 and 1 this way, that's going to be 11 and 3, or 3 and 11 if you go outer inner, and that's not going to get me to 4 either. So ultimately what that means is I can't factor it, which is fine. So I'm going to use the quadratic formula. Quadratic formula takes a little bit longer, but the nice thing about it is it always gives you an answer. Whereas factoring, it's faster, but it doesn't always give you an answer, right? That's the drawback. So let's go ahead and start to take a look at this thing. So if I'm going to use the quadratic formula, I'll just put this down here. A is going to be 3, B is going to be negative 4, and C is going to be negative 11. So if I want to solve for Z, it's going to be negative B, right? Negative of negative 4 plus or minus the square root of B squared minus 4 times A times C. Right, all over 2a. So we're going to simplify this and then match it up with whatever's going on over here. So if I'm going to do this, we got negative of negative 4, right? That's going to be 4 plus or minus. All right, so let's see what we got. Negative 4 squared is going to be positive 16. You've got a negative 4 and a negative 11 here times a positive 3. When you go ahead and crunch all of that on your calculator, because you have this negative times this negative, it's actually going to be a positive here. And when you crunch it, and you can try it on your TI-84s, you get 132. So 4 times 3 times 11 is 132. And I'm going to put that over 6. And I'm just going to shorten my radical bar here because I just don't need all of that. All right, next up is to do the 16 plus 132. So we've got 4 plus or minus the square root of 148 over 6. And now I just need to simplify this radical a little bit. Now I gotta tell you, I feel a sneeze coming on. Hold on. Excuse me, glad you got to hear that. Okay. I wanna simplify the 148. So I'm gonna put some work off to the side here so we can take a look at that. If I was gonna do 148, I can see if 4 goes into it. If 4 is going to go into 148, that's going to go, what, 3 times? I'm going to have a 28 left over. So it looks like 4 and 37. At best, this can break into 2 and 2. So it looks like I've got 2 squared here and a 37. So when I go to simplify this radical, I'm going to have 4 plus or minus the square root. It looks like I've got 4 times 37 under here. over 6. The 4, we can take that square root, right? We can move that out as a 2. So this will be 4 plus or minus 2 root 37 over 6. So as I'm starting to see my answer shape up against the answers in A through D, I can see the 37 coming through. But just looking at A, right? A can't be the answer because I have 4 plus or minus 2 root 37 over 6. That's missing the 2. So that's not going to be my answer. Now, these all have denominators of 3. So that's kind of a little indicator I need to simplify something. And all of these terms have a 2 in common, right? 4 can be divided by 2, 2 root 37 can be divided by 2, and 6 can be divided by 2. So I'm going to take out that common factor. And when I do that, right, 4 divided by 2 is 2. 2 root 37 divided by 2, I lose the 2, right? 6 divided by 2 is 3. So I'm actually looking at 2 plus or minus the square root of 37 over 3. And when I see that, that looks like D is going to be my answer. All right. Thanks so much. Bye.